Hi and welcome everyone. In this video, I want to go over the precise definition of a limit. So by now, I know you know how to find the limits by using graphing, algebraic, and tabular method. But this is a way to prove if the limit of a function exists at a point. So now we're gonna do the definition of two-sided limit. So let's go over the definition. Let f be a function defined on some open interval that contains the number a, except possibly at a itself. So then we can write limit as x approaches to a of f of x equals to L. I'm sure you have seen this notation before. However, just notice that f of x does not need to be defined at a. So we're just concentrating on the limit. We're not talking about continuity. And that's basically what we want to prove. So remember A and L. Now for this, we use epsilon and delta. So this symbol, like E, is called epsilon, and that symbol, these are Greek letters delta. So, and for all the limits, just remember these are very little numbers and they're always positive. So the limit exists such that if absolute value of x minus a is between 0 and delta, and remember delta and epsilon, they're both positive, then absolute value of f of x minus L should be less than epsilon. So what you want to do is find a relation between delta and epsilon. Graphically, let's go over this graph. That means this is our limit. X approaches to a, and then that's our limit. We get a. That means if you go to the right, a number delta, or to the left, a number delta. So this is delta, and anywhere you pick a number and you hit the curve, you're going to be in this box. So if you hit the y-axis, then that value should be between L plus epsilon right here, or you're to the left of A, you hit the graph, you're going to be in between L minus epsilon. So basically this is the graph, and if that happens, then you know the limit exists. When we are very close to A, then we're going to be very close to L from left or the right side. That's from the left side. How do you write that mathematically? So that's how you write it. So if absolute value of x minus a is between 0 and delta, then absolute value of f of x minus a is between less than epsilon. So now before we go over the proofs, you have to be familiar with absolute value of equations and inequalities, especially inequalities. So that's why I did some examples here for you. For example, if you have absolute value of x minus 2 is equal to 3, the way you solve that, you can take the absolute value bars out, and just like x minus 2 is plus or minus 3. You're going to get two equations. X minus 2 is equal to 3, or x minus 2 equal. The first one is equals to negative 3, and the second one equals to 3. If you solve them, you get negative 1 and 5. This equation has two solutions, negative 1 and 5. If I put negative 1 here, negative 1 minus 2 is negative 3, absolute value of 3. Negative 3 is 3. And same thing, if I put 5 here, 5 minus 2 absolute value is 3 and equals to 3. The second type, well, this is an inequality. If you see absolute value of x minus 2 is less than 3, that means x minus 2 is a number between negative 3 and positive 3. If you isolate x, then x will be between -5, -1 and 5. Same numbers. However, the solution of this inequality is between these two numbers. Any number you pick between -1 and 5 will be a solution of this inequality. Let's try 0. So if I pick 0, 0 minus 2 is absolute value of -2, which is less than 3, and it works. The third type, well, this is also an inequality, but you have the greater sign. If absolute value of x minus 2 is greater than 3, that means x minus 2 is less than -3, or x minus 2 is greater than 3. That means x is less than -1 or x is greater than 5. So -1 and 5, same numbers as we noticed, but the solution of this inequality is going to be outside of these numbers. So any number you pick here or here will be a solution of this inequality. For proving limits, we're going to concentrate on the middle one. That's what you need to be very familiar with. The next thing I want you to notice, if I do a number line here, we know we have the solution here. However, 2 is that number. And if I move 3 to the right of 2 and 3 to the left of 2, then still that's where the solution is. So just notice that number and that number. 2 is right in the middle, plus 3 is 5, and minus 3 is -1. Basically, is the distance. This is the distance we move to the right of 2 and to the left of 2. Now, since we're gonna be using delta epsilon, so if I say absolute value of x minus a is less than delta, that means x minus a is a number between negative delta and positive delta. So x is a minus delta, x is between a minus delta and a plus delta. Likewise, if you have absolute value of f of x minus L is less than epsilon, then f of x minus L will be between negative epsilon and positive epsilon, or f of x will be between L minus epsilon and L plus epsilon. When we prove limits, we say if that's true, then that needs to be true also. So basically, that's the concept beyond proving those limits. Now, steps for proving limits. How does this work? There are 2 steps. The first one is called the preliminary analysis. Basically, what you want to do is guessing analysis or guessing a value for delta. Once you guess a value for delta, you do find a relation between delta and epsilon. And the second step, you want to see if that works. So proof or showing that the delta we chose works. Let's do an example. Limit as x approaches to 3 of 4x minus 5 equals to 7. This is a linear function. And it's obvious if you substitute 4 times 3 minus 5 is going to give you 12 minus 5, which is 7. So just by looking at it, we know it works. But let's do the delta epsilon proof. First step, as we call that preliminary analysis, we want to say if x minus absolute value of x minus 3 is a number between 0 and delta, then absolute value of 4x minus 5, this is our f of x, minus 7, that's the limit, is less than epsilon. You can start with this inequality. So absolute value of 4x minus 5 minus 7 can be written as absolute value of 4x minus 12. You can factor out to 2, and that can be written as 4 times absolute value of x minus 3. So again, we want to say if absolute value of x minus 3 is less than delta, then 4 times x minus 3 is less than epsilon. So right away, we know there's a relation here. If we isolate absolute value of x minus 3, we get epsilon that's less than epsilon over 4. So delta can be chosen as epsilon over 4. So delta equals to epsilon over 4. But let's see if that works. So given, again, just remember always epsilon and delta are positive numbers. So you want to see if that works. So we start, and doing this, you can just start it like that. Use if absolute value of x minus 3 is between 0 and delta, then if you multiply all the sides by 4, 4 times 0 is less than 4 times absolute value of x minus 3, and that's less than 4 times delta. So we can say that 4 times absolute value of x minus 3 is less than 4 times delta. But what is this side? 4 times absolute value of x minus 3 can be written as absolute value of 4x minus 12, and that's less than 4 times delta. Absolute value of 4x minus 12 can be written as 4x minus 5 minus 7, and that's less than 4 times delta. And that can be written, you can use parentheses, separate. We know this is our function f of x. Absolute value of parentheses 4x minus 5 minus 7 is less than 4 times, but we picked delta to be epsilon over 4, and that's the same thing as epsilons, 4 cancel. So if I start from here, I can say if that's true, that implies that this is also true. So you can write if absolute value of x minus 3 is less than delta, or between 0 and delta, then absolute value of 4x minus 5 minus 7 is less than epsilon. This was our a, and this is our limit. Therefore, we can say limit as x approaches to 3 of 4x minus 5 is 7 by the definition of a limit. Let's do another example. This is not a linear function anymore. That's quadratic, or a polynomial. So step number 1, well, what we want to show, limit as x approaches to 2 of x squared plus 2x minus 7 is 1. So guessing step number 1, a value for delta. Always remember delta and epsilon are positive numbers. So let's write the statement. If absolute value of x minus 4, x minus 2 is between 0 and delta, then we should have absolute value of x plus 2x minus 7 minus 1, which is that number, is less than epsilon. So let's start with that. So absolute value of x squared plus 2x minus 7 minus 1 is the same as absolute value of x squared plus 2x minus 8 is the same as absolute value. You can factor that by writing x plus 4 times x minus 2. So we can say absolute value of x plus 4 x minus 2 is less than epsilon. So what's our goal? We want to make absolute value of x minus 2 small enough so that absolute value of x plus 4 times absolute value of x minus 2 is less than epsilon, and I wrote it here for you. Now, in this case, when you have quadratic or a polynomial or any other function than linear, you need to guess a value for delta. The best number you can pick for polynomials is 1. You can pick 0.1, 0.5, 0.01, but 1 is just makes the calculation easy, and we're going to see if that's going to work. So let's guess delta equals to 1. Let's just put absolute value of x minus 2 less than 1. Then absolute value of x minus 2 is between negative 1 and 1. Then x will be a number between 1 and 3. You isolate x. But what we want to see what happens to x plus 4. So if you add 4 to all three sides, then you see that x plus 4 will be a number between 5 and 7. So x plus 4 cannot be greater than 7, so we can pick 7 here. So, and we know, therefore, absolute value of x plus 4 is less than 7. So we start again. Absolute value of x plus 4 times absolute value of x minus 2 is less than epsilon. So we know for sure that 7 times absolute value of x minus 2 is going to be less than epsilon. So in this case, we can write absolute value of x minus 2 is less than epsilon over 7. Divide both sides by 7. We can choose delta to be the minimum of 1, the number that we guessed, or epsilon over 7. So let's see if that's going to work. Now we start, write the statement. Absolute value of x minus 2 less than delta. We have absolute value of x minus 2 less than epsilon over 7. And we know that absolute value of x plus 4 is less than 7. I just wrote that for you. So we can start by this. We know that absolute value of x minus 2 is less than delta. If we multiply both sides by 7, 7 times absolute value of x minus 2 will be less than 7 delta. But what did we pick for absolute value of x plus 4? That was less than 7. So we know for sure that absolute value of x plus 4 times absolute value of x minus 2 is less than 7 times delta. And delta was epsilon over 7, and that's equal to epsilon. So we can write absolute value of x plus 4 times x minus 2 is less than epsilon. Then we can again put those in one absolute value. You can expand, you can pick your f of x, which is x squared plus 2x minus 7 minus 1, and this is our L. And we know that if absolute value of x minus 2 between 0 and delta, then absolute value of x squared minus 2x minus 1 is less than epsilon. So they both imply each other. So therefore, the limit as x approaches to 2 of x squared plus 2x minus 7 equals to 1 by definition of a limit. Here is another example. This is also linear. And I did this a little bit different, but let's go over this. Limit as x approaches to 2 of 3x plus 2 equals to 8. Always step number 1, guess or find the value for delta. So we write the statement. This is the original statement, and again we know a is 2 and L is 8. So absolute value of x minus 2, if absolute value of x minus 2 is between 0 and delta, then absolute value of 3x plus 2 minus 8 should be less than epsilon. Now we can pick that one and write that as absolute value of 3x plus 2 minus 8 is the same thing as absolute value of 3x minus 6. And that's the same thing as 3 times absolute value of x minus 2, and that's less than epsilon. So, and we know if absolute value of x minus 2 is between 0 and delta, then 3 times absolute value of x minus 2 is less than epsilon. So we know that if we have that, then we can write absolute value of x minus 2 is less than epsilon over 3. We can see a relation here. So let's pick delta equals to epsilon over 3. The proof. Now this one, if you want to start like that, that's completely all right. So just write, we know that absolute value of x minus 2 is less than delta. If you multiply both sides by 3, then 3 times absolute value of x minus 2 is less than 3 times delta. However, 3 times absolute value of x minus 2 can be written as 3 times absolute value of 3 times x minus 2, and that's absolute value of 3x minus 6. And just take the function away, so it's 3x plus 2, that was our function, minus 8, that was our limit, is less than 3 times delta. But what did we pick for delta? We picked for delta to be epsilon over 3, and this is epsilon. So starting with that, we showed that this is less than epsilon, and I wrote it here. So if absolute value of x minus 2 is between 0 and delta, then absolute value of 3x plus 2, which is f of x minus L, is less than epsilon, so it works. So therefore, limit as x approaches to 2 of 3x plus 2 equals to 8 by definition of a limit. So that's how you can write. Next example, that's a cubic function. So limit as x approaches to 2 of x cubed equals to 8. Let's go over the steps. Step number 1, again, guessing a value for delta. So we write the statement. We want to show that absolute value of x minus 2 less than delta, then absolute value of x cubed minus 8. Our limit is less than epsilon. Absolute value of x cubed minus 8 can be written as absolute value of x minus 2 times x squared plus 2x plus 4. You just factor, this is the difference of two cubes. Then you can write that, separate them. You can write that as absolute value of x squared plus 2x plus 4 times absolute value of x minus 2 less than epsilon. So we need to see what value we can take. What's the maximum value that this takes? So again, this is a polynomial. Best value to pick for polynomials for delta, guess or choose delta equals to 1, then try to see if that's going to work. Absolute value of x minus 2 is less than 1. Then we know x minus 2 will be a number between -1 and 1. Isolate x, so x will be between 1 and 3. So we know that that x squared plus 2x plus 4 will be less than 3 squared plus 2 times 3 plus 4, and that's 19. So the maximum value that this can take is 19. So coming back, we can write absolute value of x cubed minus 1 is the same thing as absolute value of x minus 2 times absolute value of x squared plus 2x plus 4. And we know this is less than 19, so you can easily substitute that by 19, and you know that's less than epsilon. So in this case, we can write the absolute value of x minus 2 is less than delta over 19. And that's another way of writing. So we can pick delta to be 1. That's what we guessed, or epsilon over 19. Let's see if that works. So step number 2 is the proof. That's what we need to see if that statement is true. If absolute value of x minus 2 is between 0 and delta, or just say absolute value of x minus is less than delta, then absolute value of x cubed minus 8 is less than epsilon. You can start from here. Absolute value of x minus 2 is less than delta. Multiply both sides by 19. 19 times absolute value of x minus 2 is less than 19 times delta. 19 we know we can substitute by absolute value of x squared plus 2x plus 4 times absolute, or just x squared plus 2x plus 4, and this is always positive, times the absolute value of x minus 2 is less than 19 times delta. And we picked delta to be epsilon over 19. So if instead of delta we substitute epsilon over 19, we clearly see that this is less than epsilon. But what was that? That can be written as x cubed minus 8 less than delta. So we started from here and we ended here, and each step implies the next step. So if absolute value of x minus 2 is between 0 and delta, then absolute value of x cubed minus 8 is less than epsilon. They imply each other. So therefore, you can say the limit is true by the definition of a limit. So again, try some examples on your own, and if you deal with a polynomial, always pick delta to be equal to 1 and try that, and you'll see it will work. If it doesn't work and you can't find that relation, that means the limit does not exist. I think that's it for this video. Thank you for watching, and I'll see you in my next video. Have a good one, everyone.